Okay, this series of videos is basically what we're going to start out our Algebra 2 adventure with regarding solving multi-step equations. We're going to do a lot of this stuff. Everything you're reviewing here, first of all, everything is review. None of this is new, so it's very likely that you've done all of this in not only your algebra class, but also your 8th grade math class. So telling you that so that maybe when you start going, oh, this is familiar. Well, that's why, because it's up there somewhere. All right. So when we talk about solving multi-step equations, right, for algebra, it's important to understand that finding a process and finding a way to do things and sticking with that process and everything is really important to success, especially in this class, because the equations get very difficult later on, and even if they're not difficult, they're involved, right? They're very many steps, and there's a lot of ways to go wrong. So it's really important to start training yourself, and I'm deliberately using that word train. You need to train yourself to do this in a methodical way and not in your head, right? Even if you're working on Alex, you should be working in a notebook and, listing out your steps. And the reason for this is that you make fewer mistakes, and then when you do make the mistakes, you can see what you're doing. And lastly, if you're having a breakdown and you're doing something and you are regularly getting something wrong, but you're not sure why, it's a lot easier for somebody else to look through that and say, oh, okay, right? So those are like the reasons for you to show your work, right? And to list out work. And so for this, everything I'm doing, I'm going to show you a process of how to do this. And if you don't already have a process, I recommend using this one. And even if you do have a process, I would recommend considering using this one because it's will help you be successful. All right, so you're going to be solving multi-step equations involving combining like terms and the distributive property, all right? And so we'll start with very simple equations, and then we'll move into ones that are more involved. So let's get started here. All right, so what we have here is we have a couple of what I would call two-step equations, right? And you know they're two-step equations because there's usually two terms on one side and one term on the other. And then there's usually an adding and subtracting step, and there's a multiplying or dividing step, right? And so that's kind of what we're looking at here. So for all of these, I always recommend kind of putting in a fence, right? And I'm going to work using a vertical method. So my vertical method uses more paper, but it works well and it's more organized and it's easy to follow. So 2x plus 7. So the goal with algebra, all right, solving any algebraic equation is always to find a way to get x by itself. Now, you have to do two things to get x by itself. First of all, you have to get all of the x's together, right, on one side. And then once the x's are together, you want to get it down to just one x, right? And that's our process with getting it together. So the first thing I always do is I look and I find where x is. All right, x is right here. And then see what's happening. Well, it's being added by 7, and then on the other side of the equation, you have 31, right? And so we're dealing with a balanced equation here, right? This is a balanced equation. So if you think of it like a teeter-totter, something like this with a bit of a fulcrum there, and we've got 2x plus 7 over here, and we've got 31 over here. And right now, these perfectly balance each other because that's what the equal sign says. So the idea is that whatever we do to one side, we have to do to the other side, otherwise we're going to throw it out of balance. For example, I'm going to take this 7, right, and I'm going to move it over to the other side. Okay, so essentially what I'm doing is I'm taking 7 away from here. And think about that language, taking 7 away, right? So to take 7 away, you would subtract 7. Now the thing is, if I take 7 away from this, that's going to make this side lighter than this side, right? And then this thing's going to go up on the teeter-totter, and this side's going to go down. So we have to take the same amount away from both sides, And so that's what we're going to do. All right, we are going to subtract 7 from both sides. We're going to go minus 7, and then that is going to give you 24 over here, and then that's going to give you 2x. And so what this means when you have 2x is it means this. It means you've got two groups of something, and I'm going to do a visual because these usually work well, that equal 24, right? And so your job is to say, okay, two equal groups that add up to 24, how much is in each group? Well, if I phrase it like that, most of you have no problem answering that, and you can say, oh, it's 12, right? You just take 24 and you divide it by 2. But that's exactly what you do with these, is you look at what your coefficient is, because this is saying 2 times x, and the opposite operation of multiplication is division. So you would say, okay, I'm going to divide by 2, and I always use fractions for division, okay? You're never going to see me write this in unless I'm making a special point, but I just don't use it because it's messy, right? And so we're going to use division here. So we've got 2x divided by 2, and because I'm doing it to one side, all right, I'm basically taking half of the x's away on this side. I got to do the same thing, and I got to take half of that away over there. So we're going to divide both sides by 2. So that's going to give me x is equal to 12. All right, and then at this point, you have your answer. Your coefficient is 1 group of x, because that's what they're asking you to find. When they say find x, they're saying what's the value of one group of x. Is 12. So what we're going to do now is we are going to put our solution back into the problem to make sure it works. And I recommend doing this for every time you solve something because it's just a good way to check, right? So 2 times 12 is 24 plus 7. Just copy the rest down. Now we're going to add this, and we get 31 over here. Copy this down. Is this a true statement? It certainly is. It's true. And because it's true, you check it off and you say you're all good, right? And then I always like to box my answers so that it's pretty clear where it is. All right. So that's the general process kind of what we're doing here. There's going to be more examples to follow. Okay, if you want to try this example now to see if you understand, go ahead. Okay, so hopefully you've tried this. Recommend pausing the video. I should have said that, but I didn't. So really quickly, we'll go through this. So set up your fence, right? Let's switch back to black here. We're going to add 8 to both sides. The reason we're adding is because we're subtracting it here, so you always do the opposite, right? And so the opposite of adding is subtracting. So if we add 8 to the other side, this gives us 30. It cancels out here. And this gives us 5x is equal to 30. This means I have 5 groups of something that all total up to 30, 5 equal groups. So we'll divide by 5 to see what's in one group. And in one group, we have 6, right? And let's do our final 5 times 6. So I'm plugging this back into this equation right here. Minus 8 equals 22. Well, you get 30 minus 8 equals 22. 22 equals 22. And you have... you got your check, that works out, right? And then let's box our answer. So that's how these work. All right, next video we'll look at some other permutations of this.